going to talk about some basic properties of logs. These are not all of the properties. Some basic properties of logs. These are just very, very basic. I have another video with the other properties. These are just a couple real quick basic properties. So the first one that I just want to talk about is, I said log. Log of 1 is always equal to 0. Log of any base, actually. Why is that true? Because if I convert that into exponential form, a to the 0 is equal to 1. Anything to the 0 power is always equal to 1. So it follows that same rule of exponentials. But in log form, it looks like this. Log base a of 1 is always equal to 0. So for example, let me just do some examples here. So log of 1 is 0. Base 10, right? Log of base 10 of 1 is 0. ln of 1 is 0. These are all the same thing. It doesn't matter if I write log base 5 of 1 is 0. These are all true. Okay? Anything log of any base of 1 is always equal to 0. The second rule, log base a of a to the x is x. Why is this true? So if the bases match, so why is this true? Well, the base a raised to the x power is equal to a to the x. I get a true statement in exponential form. So let me show you an example. Log of 10 squared is 2. Why? Because 10 to the second power is equal to 2. Log base 5 of 25 is 2. Why? Because log base 5, 25 is 5 squared, is equal to 2. 5 to the second power is equal to 5 to the second power. So anytime you see a base of a log matching a base of an exponential attached to it, they almost kind of cancel each other out if you want to think about it like that, and it's equal to the exponent. So here's another one. Let me erase that. Log of 1,000. Well, this is the natural of the common log because the base is 10, right? No base is represented, so it's automatically base 10. And I'm going to rewrite 1,000 to have a base 10. So that now they match, it's equal to 3. ln of e squared is 2, right? This is a base e. If the base matches this, they kind of cancel each other out. ln of e to the 4th is 4. ln of e is 1 because the exponent here is 1. So this is using that rule here. When the base matches this base, they cancel each other out. It's equal to the exponent. And then one other little basic rule of logs, a to the log of base a to the x is equal to x. So let me do some examples on the next page. Let me mix up these properties. Let's just randomly do some problems real quick. So I want to simplify or evaluate each of these expressions, logarithmic expressions. So the first one, log of base 3 of 27. Well, I'm going to rewrite this and use the second property here to make these bases match. Because I can make 27 an expression of base 3. Now, if I couldn't do that, then this rule would not work. So if this was anything other than a number that can be represented with base 3, it wouldn't work. So these 3's will cancel, and that's equal to 3. Log of 0.01. Be careful with these because I can rewrite 0.01 as 1 over 100. And then just using properties of exponents, this is 10 squared. Log of 1 over 10 squared is 10 to the negative 2. So 0.01 is the same thing as 1 over 100. 100 is represented as 10 squared. And 1 over 10 squared is 10 to the negative 2. And the base of this log is 10, so they cancel each other out, and this is equal to negative 2. Play on numbers. ln of e to the 5th is 5. Know this one, ln of e is 1, okay? Because you'll see that a lot. Let me go to the next page so I have space. 5. 2 to the log of base 2 of 3 is 3. Think of it as the opposite direction. This is an exponential form, and the exponent of this exponential base is log. But the bases match. Think of them as canceling each other out, and it's equal to this value there. So e to the ln of x is x. 10 to the log of 4. This is base 10. This is 4. Log base 7 of 1 over 49. I'm going to rewrite 1 over 49 as 7 squared because I'm trying to create the same base, match the base of the log. And this is 7 to the negative 2, so this is negative 2. So I'm just playing on these properties, and you want to be really good with them. So practice, practice, practice. These are the basic properties of logs.